The C is our constant. The B is kind of our middle term. And then the A is the lead coefficient. So there's going to be 4 things you want to know when you're graphing for standard form. If A is negative, it opens down. So when I say opens up or opens down, if you've never looked at a quadratic equation is kind of this. So when it opens up, this is an opening up. So the ends go up. If it opens down, it would look, so the ends would go down rather than up. Second thing you want to know is the y-intercept, how to find the y-intercept. So the y-intercept is pretty easy. So it's 0, so we're going to write this as a coordinate. 0, and then whatever C is, whatever this C up here, the constant is, that's going to be in your y-intercept. The third thing you want to know is how to find the axis of symmetry. So we call this the AOS. So the AOS equation is x equals negative b over 2a. To solve it. So in order to find the vertex, you need to find the AOS first, because the AOS kind of determines where the vertex is going to be. So the vertex equation is, so the way this works is, whatever you get for your AOS, that's going to be the x term of your vertex. And then you're going to take that x term and plug it into the quadratic equation up here. So we're going to graph this quadratic equation. First of all, we're going to want to identify the A, B, and C. Start with the A first, because the A is going to be whatever the lead coefficient is right here. So since there's only an x squared, so A is going to be 1, so because there's 1 x squared. B is our middle term, so it's going to be a positive 4. C is going to be our constant, which is a negative 2. We're going to determine whether the graph opens up or down. So A is a positive 1, so that would mean that the graph opens up. Let's go ahead and start with the easy stuff first. We're going to find the y-intercept. So our y-intercept, remember, is 0c. The y-intercept is going to be 0, and then our c, identifying it right there, is a negative 2. So it's going to be a 0, negative 2. Now on our graph over here, so after this, after we found the y-intercept, we're going to go ahead and find the AOS. So we're going to write it down here. The AOS, remember, that's going to be up there. That was x equals negative b over 2a. So up here, we're going to have our b. We identified it up here. Our b is a 4, positive 4. Going to be a 4 up there. And then our a, which we identified as 1, so our a is going to be a 1. So if we solve this, which we know as negative 2. So this is our AOS. So we're going to write this on the graph just kind of as a guiding point. So our AOS is going to be negative 2. Our vertex is going to be somewhere along this x equals negative 2 line. So in order to find that, we're going to plug them in. To find the y of our vertex, if you remember, it's f of the AOS. So we're going to go ahead and do that. Our negative 2, so a negative 2 times a negative 2. So it's f of negative 2 equals, so negative 2 squared, 4, or minus, actually. So 4 times negative 2 is a negative 8. So minus 8, and then our constant, minus 2. 2 is negative 6. So this is our y, the vertex. So this is our vertex. We're going to plot our vertex, which is negative 2, negative 6. Previous knowledge. If it's not previous knowledge to you, don't worry, I'll explain it. Our parent function is f of x equals x squared. That's the parent quadratic. That would start at 0, 0, and right 1, up 1. And then so the next coordinate we go to is right 2 up 4, and then right 3 up 9. And then so now that we have which way goes right, it would just reflect it when we go left. So as if x, or the a, is 1, which in this equation our a is 1, so it would stay the same from the parent function. So all we need to do is kind of plot those. So down looking at the graph again, we're going to go right 1, up 1. So this is our first point, and then another easy trick you can use is you reflect it over the AOS if you've drawn the AOS out. And then the second time we go right 2 and then up 4. And look at that, we've already got it plotted because that's our y-intercept. So once we have that y-intercept plotted, it should fall along the graph. So right there. And then our last point we'll do is right 3 up 9. So our last point, as you can see, the graph gets bigger and wider as it goes up. We're just going to plot that just so you guys can see kind of where that is. So that's going to be a 1, that's 1, 3, and then if you come over here, it does kind of go off the graph. So we're going to go over one more from the last point. So this is kind of our first basic quadratic equation. So, and that is our first equation. Okay, so this is the second equation we're going to work. Again, we're going to want to identify the a, b, and c. So the a is now 3. And then the b is same thing, middle term right here. That is a -8. And then our c is a +6. And the y-intercept. So the y-intercept is 0, and then whatever our c is, and our c is 6. So the y-intercept is 0, 6. So we'll go ahead and plot that on the graph now. And then the lead term coefficient is positive, so we know it opens up. And so let's go ahead and try and find the AOS. So our AOS equation, if you remember, is x equals -b over 2a. So let's go ahead and plug everything in. So our AOS is x equals -8 over 6. Okay, so our x is going to be, so we're going to do -8 divided by 6, which is -4 over 3. So that simplifies to -4 over 3. So the negatives cancel each other out and turn that 4 into a positive. So we're just going to have 4 over 3, which is about 1 1/3. Our AOS is 4 over 3. With our AOS being 4 over 3, we'll do the same thing we did a little bit ago. We're going to kind of like do a little dotted line around where the vertex should be. To find the vertex, we're going to plug 4 over 3 into our equation. Okay, so 4 over 3 squared is 16 over 9. So so we're going to do 3 times 16 over 9. Got to be 16 over 3. And then 16 over 3 is about 5 1/3. So let's do, it's 16 over 3 minus, so 8 times 4 divided by 3, 32 over 3. So 32 over 3 plus 6, and then we'll make this a fraction too. So 18 over 3. 16 minus 32 is -16 plus 18 which is 2. So our y of the vertex is 2. So our vertex is going to be 4 over 3, 2 over 3. So that 2 over 3 is not quite 1, but almost. And so that 4 over 3, I find the points. The lead coefficient is not 1, so the table isn't going to be the same as the parent function. Right 1, right 2, right 3. We're going to go right 1, right 2, right 3, but instead we're going to... Okay, so I had originally encountered some recording errors when I recorded this part. I'm just going to kind of quickly go over that. I'm going to plot these points on the graph. Of course, we probably would plot this one because way out of the graph. So it goes like, it's like way out here. So we weren't going to plot that, of course. So what we did go ahead and do is we plotted, and then this one, it also went off the graph, so we didn't plot that. So we did plot the 1, 3, and then we also used the y-intercept as another point. And so we reflected the y-intercept over the AOS to get our this point over here. And so this is how you would graph this type of equation. Graph is negative 3x squared plus 6x. Notice that there's no c there, so our c, we're going to go ahead and identify it right now, not 0. Our b, middle term, is 6, and then our a is just negative 3. Go ahead and find the y-intercept first. 0, like it always has been. So our y-intercept is going to be 0, 0. That's a little bit different because it intersects the y and the x-axis at 0, 0. Once we have that, we know that that's going to be one of our points. So next we want to go ahead and find the AOS. And our A is a negative 3, so we'll just go ahead and put that in there. And our B is a 6. Negative 6 over negative 6. Our X is so simply equal to 1. So our AOS is 1. So what we can do is we can do our little... so once we have our AOS is 1, we can go ahead and start finding the vertex. Vertex is going to be 1, and then f of the AOS. So we're going to do f of... So 1 squared, remember order of operations, do 1 times 1 is 1, times negative 3 is negative 3, plus 6 times 1 is 6. So negative 3 plus 6 is 3. So this is our y coordinate in our vertex. So our vertex up here is 1, 3. So 1, and remember that our a is negative, so the graph will be opening down. We have this, we need to go ahead and start graphing. So remember our parent function, it's the table would be right 1, up 1, right 2, up 4, right 3, up 9. So we're still going to keep that trend going. We're going to multiply all those numbers by 3, because that is our a, and our a acts like a slope. So we're going to multiply all these by 3. So 1 times 3 is 3. So 4 times 3 is 12. And then 9 times 3 is 27. So since this is going to open down, it's going to go down. So we're going to go to the right 1, and then the same thing on the left side. And look, there's our x-intercept and our y-intercept. X equals 0. And x equals 2, 2 and then 12. So, and then we'll reflect that over the AOS. That's about as far down as we're going to go, because 27 is going to be like way down there. So we're going to graph, and that is how you graph that equation.